Hey class, hope you are doing well. This is Young and I'm doing this recording just to walk you guys through entity relationship diagram. Hopefully this video helps to clarify a couple of confusions that students have emailed me and asked me about. And also since this week is your test week, hopefully this video will also help for you to understand more about the materials that you have been studying. So first of all, this is just a blank draw.io diagram, right? I am in the general. Whenever we are to model any ER diagram, the first thing we need to identify is an entity. Many of you seem to have confusion of what entity is. Well, entity is a thing, a person, anything is basically is a noun. And attributes are the things that help to better describe more about that entity. So for example, if you have say me, young, right? I am a person. So you would put young as the entity here. Just for example. And then how would you describe young to somebody else? You would obviously go based on the characteristics that describe me as who I am. For entity, you only want to use the square box, right? For attributes, you want to use the oval or circle box. So first of all, what can you use to describe young or a person? Well, first of all, probably my name, right? First name and last name. So maybe this won't be, maybe this should be, I'm just gonna say a person, right? So young is a person, and then for first name it would be young, right? So young is an actual attribute. After young, obviously you have last name would be ho. So young is one attribute that can describe this person, and then ho is another attribute that can describe this person. This attribute represent the first name. This attribute represent the last name. What else can be used to describe me? And then obviously my age. I'm not gonna give you my real age, so let's just say 18. So once again, 18 is a number that can represent me or characterize me as who I am. It is an attribute that describe me, describe young as a person. What else can describe me? Well, maybe my profession, right? So I'm both a software engineer and I'm also a professor, right? We can go on and on and on. You can also describe my height. I'm pretty short. I don't like to say I'm short. I like to say I'm fun size. So I'm 5 feet 4. That's also height, right? So all of these right here are characteristics that describe young as a person. So whenever you're talking about a person, you have first name, right? First name, last name, age, height, profession, right? In this case, this person has two professions, so you have both professor and software engineers. But these right here, these circular or oval box represent attribute. Attribute are characteristics that better describe the entity that you are talking about. In this case, the entity is a person, right? So hopefully this help out a little bit. So if we are to redo this, then for the person entity, some of the attribute that you would have would be name, right? First name. You can also have last name. You can have age, right? You can have social security number, right? I pressed the wrong one, my bad. Social security number. You have job or profession or jobs, right? So all these are attributes that describe this person, right? So among the attribute, there is something known as strong attribute and weak attribute. We're not gonna spend time discussing those yet, but just one key thing. If you have to pick just one attribute that can uniquely identify this person, if there is such an attribute like that that can uniquely, once again, uniquely describe this person, then that attribute will be your key attribute or strong attribute. In this case, well, my first name could be similar to other people. Same thing for my last name, my age, right? Many people are my age 18 years old. Many people have the same job as I am. They either software engineers or they could be professor. Social security number, this sounds interesting. So social security number could be uniquely used to identify me as who I am. Your social security number won't be the same as your team member's social security number. And so in this case, social security number would be your strong attribute. Strong attribute means that attribute can uniquely describe the person among all other persons, right? So that attribute alone can describe a person. Once again, that attribute can uniquely describe the person. So this what entity and what attribute mean. How would you go from identifying relationship? Well, whenever anyone talking about relationship, the first thing you should always ask is what scenario are they discussing about? If we are discussing the scenario that students go to school, right? Then that scenario you have to identify the two attributes in that relationship. Student go to school. That statement only describes student and school. It does not talk about professor, does not talk about anything else. So if we just have to model that relationship, first thing is identify the two entities that are key in that relationship or in that statement. Student going to school. The first thing that you would have is student, right? That's one entity. The next thing you have is school. Remember, what we're trying to model is the scenario of student going to school. So student in school, and whenever you discuss about relationship, what you usually use is a diamond box, right? You would just map those two together, right? Student goes to school. So in this case, you have student and you have school. If we are to repeat the first process that we did of identifying the attribute that can describe about the entity, then some of the attribute that can use to describe student will obviously be still first name, last name, right? You can arguably say social security number, but that's not very common. Whenever we identify the attribute, we try to stay as close to the entity in the context as possible. When you talk about any student, you're not going to say, "Oh, that student's social security number is due to any other," because you don't know or you shouldn't know it. It should be something private. So maybe you can have age, you can have student ID, right? Student ID is not the same as social security number. Each student has an ID, right? That is what uniquely identify you. Perfect. So student ID is uniquely identify a student. So in this case, student ID would be your strong or your key attribute. Every other attribute would just be a regular attribute that used to describe about the student. So you have student ID, student age, or you may even have student rate level, whether they are freshman, sophomore, junior, or whatever. The interesting thing here is some of the um, presentation that you have read talk about derived attribute. Derived attribute means when one attribute can be used to derive the other attribute. Arguably, if you have age, you know someone is 19, someone is 20, 21, 22, you can guess their rate level. So if someone is 19 or 18, more than likely they would be freshmen. Someone is 20 would be sophomore, 21 junior, 22 seniors. So in some cases you might not need rate level, because that attribute can be derived from another attribute already or vice versa. If you know the rate level, more than likely you can derive the age, right? So you don't need to have both, but it's okay to have both. It doesn't hurt anything. You would then connect all these attributes obviously to student, right? We can go on and on and on, but hopefully you get the context. Once again, attribute are basically characteristics that can be used to describe more about the entity. So you have all those attributes for student. You need to identify attribute for school. School, obviously, what's the name of the school, right? That's one attribute. School establishment year. What year did the school establish? Right. Remember, attributes are also nouns. So try to think of a noun that describe what you were discussing. If you're talking about establishment year, then just say establishment year, right? Name, school, maybe max capacity, how many students can the school has, right? Right, address, stuff like that, right? You get the idea. Now, your lab one and lab two simply ask lab one simply asks you to identify the entity. It first asks you identify the business function and then identify the entity. So if you can identify all the entity for the given business function, then that's all you need to do for lab 1 part 1. Lab 1 part 2 asks you to could you link two entity together among all the entity that you have identified. Can you link them together? So if say you have hospital and you have nurse, right? One of the scenario is nurse work at hospital. That's their relationship. So you would have the nurse entity connect to the hospital entity and the relationship with a nurse work at the hospital. After you have that relationship mapped out, go ahead and identify attributes or characteristics that can describe more about the nurse and more about the hospital, similar to student and school. If you give me something like this, that's all you need to do for lab 1 part 2. Lab 1 part 1 simply asks you to just identify the entity, just write them out on paper. That's all. Okay? So if we want to continue elaborate on this example, let me move this now. So lab 1 part lab 2. Lab 2 talk about subtype and supertype. Okay, perfect. Let expand this a little bit more. Let me just remove ray level just so I have some space here, okay? Now let's add in another relationship, professor. So what does professor and student have in common, or what do they how are they related? Right? Professor teach student or student taking classes from professor. So the relationship here is teach. Alright? Professor teach student. Okay? See that? When we model, if we connect one entity to another, try to identify what is the relationship between those two entities. And as you go connecting that entity to more, you have just elaborate or expand your ER diagram to be a lot more complex. We started out with just a person, right? And this person was a student. So we went with student, we identified all this attribute. Then we identify the school, which is another entity. Student and school relationship is that student goes to school. So we connect those two entities together. Now we introduce professor. Professor teach student. Professor work at the school, right? So if you want, you can also have this professor work at school, right? So for the purpose of this, let me just remove those two attributes so I have some space. That's all, right? Nothing fancy, just so I have some space. Because hopefully by now you guys understand this and repeat the process, right? Professor attribute. Age can also be used to describe professor. Professor may have salary. Student don't have salary, but professor does, right? Professor also have first name, last name, right? First name, last name. I'm just gonna say first name. Professor can also have address. Student can also have address, for example. So let me put address here or for student as well because I'm about to do something that you guys will see in a second. This should be enough. Right. Oh, okay. Why don't we add one more? Any of these can they be uniquely identify the professor? You can argue that address can uniquely identify the professor. But what happens if I ask you, can some other people live in the same address as this professor? Maybe his family member, right? Or maybe his son or his kid, right? The student can be the professor child, right? So address it could be used to identify professor, but it's not doesn't make sense. Now professor might have a professor ID, so employee ID because the professor work at the school, so professor has employee ID or social security number. Okay, let's do both. Let's do employee ID and let's also do social security number. I'm just gonna put SS, okay? All right. Now lab 2 asks you to identify type and subtype, which means among all my entity, can I group any two similar entity together into just one type? So let me copy this. Let me move down here. If we look here, we can say that professor and student are both human, both are person. So we can group those two together for sure. And we can have something like a person, right? A person can be a student. A person can also be a professor. A professor can be a person. A student can be a person. If you have this, usually to identify type, you would use a triangle box. So in this case, you would have a student is a person. A professor is also a person, right? Let me put this here, right? Yeah, excuse the join. Not trying to be so fancy, just hopefully get the idea straight. This would be is a. A person is a student. A person could also be a professor. The interesting key here is whenever you try to generalize entities like student and professor can be person, try to identify any attribute that could be shared among those two. So some of the attributes that can be shared obviously gonna be first name, last name, age, and let's just say address, right? And interestingly, maybe social security number. Remember, those are just attributes that describe this person. It doesn't necessarily mean those attributes have the same value, right? So value mean student name is Nick, professor name is Young. Those are two different values, but in terms of just attribute, they are the same attribute. They both come from attribute first name, right? So you can have social security number as still the key or the strong attribute that can be used to describe any person. So social security number would be your key attribute. You would have this and you would just underline it. That's how you represent key attribute. Alright, cool. Whenever you see this diagram, that means all these attributes of the supertype will be inherited by the subtype. So student and professor will automatically inherit all the attribute belong to the person, right? That's what it means. Now, student can also have something uniquely belong to him or his or her. So what uniquely belong to the student may be student ID, right? So student ID, and professor would obviously have professor ID, right? Student have rate level, right? You're not gonna have rate level for professor, or maybe you do because a professor might teach a specific rate, but for this case, let's just assume rate level is unique to the student, right? Something else that also unique to the professor that student won't have is salary, right? So you see how we just went from having student and professor with the relationship of teach. This relationship could still remain. A professor still teach student, right? But professor and student are subtype of person. All those attributes professor and student will inherit from person, but student has student ID and rate level that are unique to the student entity. Professor has professor ID and salary that are unique to the professor, right? So this whole diagram is what lab 2 is asking you. Basically, just try to look at your existing diagram and see if you can generalize any of the entity into subtype and supertype. Supertype means person, subtype means student and professor, right? So whatever their relationship to school would still stay the same. So you would still have school here, and then person go to school, professor teach or work at school. So that's everything. See all those attributes here, right? So last name, age, first name, social security number. Those are attributes that can be generalized as well into the supertype person because regardless if you are a student or a professor, you will still have those attributes. But attributes such as student ID, grade level, are unique to the student entity, whereas professor ID and salary are unique to the professor entity. If your supertype is not person but employees, then it doesn't make sense because a student is not an employee of school, right? And an employee cannot be both student and professor. Well, in some cases, actually, you can, because some students work part time, so some students are also employee. So if you change this to employee, you are not wrong. You're still right. But in this case, what you could do is you could have both social security number as well as employee ID, right? So if it's employee, now you can have employee ID to be an attribute from the supertype. And if that's the case, you would remove professor ID. You will still have student ID. Student ID is different from employee ID. So in this case, in this relationship, whenever anyone look at this diagram here, they would know that social security number, employee ID could be used to uniquely identify this employee. In this case, that is true for both student and professor if the student is an employee. But in case where student is not an employee or student is both a student and employee, then student also have student ID as an attribute that could uniquely identify student among all the other students. So the student entity would actually have student ID, employee ID, and social security number as three key attributes. Sometimes we call that aggregate attribute. Aggregate attribute mean when you have more than one attribute of the same type that can uniquely identify that person. So in this case, social security number, employee ID, and student ID are aggregate attributes that could be used to describe student. But when it comes to professor, you would only have social security number and employee ID to uniquely identify the professor. You see the difference? Right. So if you turn in something like this for your lab 2, that's all I asked for. Right. Now, in later presentation or lectures, which we will dive more deeper into cardinalities, but right now it's not necessary. But hopefully, this little demonstration helped to clarify some of the lectures a lot better, as well as helping you guys to know how to draw a diagram. Some of you actually give me table format, right? Those are not wrong. Those are actual database schema, but we aren't getting there yet. The whole point of this is you can quickly draw entity and attribute, because a lot of time at work, what you would do, you would whiteboard. You're not gonna whiteboard draw an actual table like what some of you has turned in. What you would do a lot of see a lot is people just draw, square boxes and then have circle boxes so they can quickly illustrate the idea and concept. And then when it comes to implementing the Excel database schema, they would put these into that tabular format just so it closely represents a database schema. So regardless if you have them in this format or in those tabular format, both are correct. None of them are wrong. Okay, but really what I'm looking for is just this. This is what we are studying. So hopefully that helps. If you're still confused, please email me. I do my best to explain to you, but that's all I have. Thank you.